Hi, my name is Stas, and today I will be sharing with you a topic of ultra-portable applications via DAPR and Azure Container Apps. DAPR and Container Apps are getting traction these days, and a lot of companies adopting them to concentrate on delivering a quality solution and not concentrating on the DevOps side or even starting project without any DevOps engineers. But let's begin with some information about myself. As I mentioned, my name is Stas, and I have over 17 years in IT. I changed a lot of positions from development to management and back to development again. I've been a CIO, project manager, team leader. I was software architect, and now I'm solution architect. So a lot of background, a lot of experience, and this allows me to look onto the problems from different perspectives. I'm also Microsoft Most Valuable Professional in Azure category. Microsoft MVP program is a program that brings technical experts who sharing their knowledge with community. This program spans the entire world, and there are about 4,000 MVPs around the world at the moment. I'm also a Microsoft certified Azure Solutions Architect expert, which allows me to tackle any complex projects with Azure platform and build a wide range of types of products from data platforms to classical .NET applications, containerized applications, and so on and so forth. I'm also co-organizer of Microsoft.NET user group Odessa. This is a great local community of .NET and Azure engineers located in Odessa. So you can join us by searching the hashtag, by finding us on the LinkedIn, Meetup, or the Facebook. Also, as I mentioned, I work in a solution architect at the moment, but I'm still writing code and preparing prototypes, solutions, and writing codes for the production projects. I'm also mentor at IT School and Atom Space. This is a local Odessa community for youth. It's a branch of Code Club, the global movement for educators. I'm working at Capgemini Engineering. It's a great company, and you can find more about this company on social networks. And also, I'm your friend and neighbor, so you can just contact me or ping me back about this talk via social networks or YouTube, or you can find some additional posts about these topics on my blog on the Medium. And don't hesitate to contact me and ask a question, because I'm always gladly help anyone who came to me with the questions. So let's proceed with our talk. So let's talk about Open Application Model. Open Application Model is created by Microsoft basically, and now it's open sourced. And the main goal of this modular approach is to concentrate on code, on features, and allow your application to be deployed on any cloud, on any environment. And you can have it on premises, you can have it on the edge, and you can have in different clouds, and you will get the same results, because observability, control of your application, and etc. would be the same regardless of environment. And from my perspective now, the major problem with DevOps overhead for the projects, it's kind of slowing down the overall delivery of products that you developing. And I'm talking now from the perspective of developer, not an architect, not a DevOps engineer, and etc. I'm just talking about that your code and shipment of your code should be your responsibility, and you don't have to rely on DevOps engineers or any infrastructure concerns. So you should develop your code. It should be running on your environment, and the same goes to running into any cloud that you want to deploy it. And now let's talk about separation of concerns. As you might already know, there is a lot of boilerplate to be created for your app to be deployed in cloud or in production, doesn't matter, it's cloud or on premises. And it's getting harder and harder to do this with application growth. And moreover, you have a lot of obstacles with deployment on different clouds, different environments. And to make your application portable is super hard nowadays. Because of this lack of portability, you might end up with vendor lock-in, because you're getting used to the particular cloud. And deploying an application, let's say from Azure to AWS, might result in a lot of refactoring and optimizations for the different services that are located in AWS. But you can tell that you're using containers, and so your application is super portable, but you're forgetting about stuff like observability, portability, extensibility, and etc., which will block development of your application on AWS as well. And by using this model, you can be sure that your application will be portable, extensible, and can run on different clouds without any issues, because things like observability, service discovery, connectivity, and etc. would be out of the box with this open application model. And so this is a step forward in the right direction, from my perspective at least. Let's go into deeper details. So DAPR, what is DAPR? Distributed Application Runtime that allowing you to run your application on Kubernetes. On Kubernetes in any cloud. Moreover, there are managed solutions now for Kubernetes with less hassle and less maintenance from your side. And your application will be running the same way on any Kubernetes cluster deployed anywhere. And also it can be run on the local environment, but we will talk about this later on. So, is it another hybrid framework, or it's something great and useful and something that can ease your life as a developer? Let's figure it out. It's written in Go, and it supports a lot of languages, a lot of platforms, but as I mentioned, it's also supported by the Windows servers and can be used on this platform without Kubernetes. All internal communications in DAPR are made with JRPC, but it's also supported HTTP, so it will be your choice to select a proper protocol for communication between microservices. So it will be your choice to select a proper communication protocol between your services and sidecars. It also supports hosting on the Azure Service Fabric, and internal support of Azure Functions is a top-notch. And it can be deployed on any cloud, as I mentioned. Actually, Alibaba Cloud actively contributing to the DAPR because it's open source. And it's a first-class citizen on Azure platform and Alibaba, but also can be easily deployed on any cloud, as I mentioned. The one downside here is not supported by Nomad yet, and hopefully the HashiCorp and Microsoft will find a way to integrate them together. And also it have a great actor framework support inside. It's based on reliable actors of Service Fabric and Aglins. And so you can get rich functionality for actor framework just inside your DAPR application. And so you can easily leverage the actor framework from the DAPR. And also DAPR have an awesome community and monthly calls with community where you can participate or contribute or ask for the help. They have a great Discord channel also. You can navigate to the DAPR community on the GitHub and find all resources that you need. And moreover, a lot of companies already leveraging DAPR and using it in production. So, key facts. DAPR is application layer for developers. It's concentrated on developers, not on DevOps and infrastructure. It's not a service mesh per se because it's supporting network discovery and etc. But it's not the main goal. The main goal is to ease the life of developers. It also have this standalone mode where he can run as a process on your Windows machine or on server machine with several containers. DAPR C# actors based, as I mentioned before, on Aglins. And they're super powerful. It's the latest and fanciest implementation of this framework. You can access DAPR runtime via SDK, via JRPC or HTTP. So if something is not supported by SDK at the moment, you can call DAPR runtime via HTTP or JRPC and get the needed results. You will also get a rich integration with a lot of Azure native services, API management, logic apps, functions, and etc. And you will get another command line tool, which is might be not super good, but if you get used to the command lines, you can get additional command line options to build and run your project. It can handle service-to-service invocation and discovery. It can do the state management for you with help of non-relational databases. It can do a pub-sub functionality, so you can easily subscribe and publish messages to message brokers. It can do resource binding and triggers, so you can just plug in additional services with ease of use. You can use actor framework, which is so super powerful. You can leverage observability, which is, from my perspective, it's kind of crucial component and super great component from the DAPR because automated observability, correlation ID generation for logs and etc. is super fun and super easy to use because otherwise it can be a painful process. It can also handle the secrets for you, and it can be easily integrated with other key vaults like Azure Key Vault or Hash Vault as well. So how is the DAPR working? It's working in Kubernetes, as I mentioned before. It have 3 system pods with placement service, with sidecar injector and operator. For each application you have deployed, you will have a sidecar responsible for integration with any site services like Statestores, message brokers, and etc. Key vaults, storages, and this allows you to use any components. Just reference the state storage and then select which kind of storage you want to use for your storage component and switch these components on demands. So if you're running on premises, you're using RabbitMQ and other storage services. But when you switch in your application to the cloud, you can use Azure Service Bus and different type of storages that are present in the cloud. And this is what most exciting thing for me, because it's working super great, flawless, and we're getting into details soon. Let's talk about JRPC. It will be super brief overview. It's a super fancy protocol with protobuf payload. It's binary, it's small, with integrated security and integrated bidirectional streaming. And this is the main selling feature of this protocol. And as I mentioned, DAPR is written in Go. And communication by default between DAPR sidecars and placement service and etc. happen via JRPC protocol to speed up activity. Yes, it's super chatty, and this might be additional problem with the huge applications, but this is the problem for another day. Let's talk about self-hosted mode. If you're a hardcore developer or you have a legacy application that needs to be gradually ported to the DAPR and then deployed to the clouds, or different platforms or on-premises Kubernetes, you can start with a self-hosted mode. It's a normal mode with Docker containers, with most of the features supported. You will have a Redis container for the Statestore. You will have a Zipkin actors and mutual DNS name resolution in the self-hosted mode too. You need to set up everything manually, so DAPR, if you install it on your system, can set up Redis and etc. But for reliability and portability, you should create everything by yourself. It also have a lean mode without Docker, but it's for super exotic applications, I think. This lean mode can be used with Internet Information Servers on Windows. I'm not sure about application scenarios, but it can be super mega legacy application that you still want to use with the newest and fanciest technology. Maybe port your .NET 4 application to the .NET 6 and then use DAPR for some kind of observability purposes and etc. But main obstacle, as I mentioned, is a lot of manual setup, but otherwise you can have your image of Windows Server with Docker deployed there and additional containers for the state and etc. And this way you can ship your on-premises application with DAPR for your internal networks in enterprise. So let's talk about actors briefly. Actors is a specific framework, and if you really need it, DAPR can handle this for you. It can handle the actors hosting and management, discoverability, state storage, and etc. You can see the sample schema of how it's working with actors, and obviously it's based on the Orleans and Service Fabric reliable actors. It's working great, but you need to have these special requirements to use the actors, and it's a kind of next step. If you have any kind of payment application or ticket processing, actor framework on the DAPR will help you to solve these problems. And it's not available in all languages, obviously, because it's a port of the Orleans and reliable actors, so it's leverage all power via C#, but you can use a DAPR API to call your actors and to handle them properly. So let's dive deeper into details. Service-to-service invocation via DAPR. DAPR brings to you discovery, namespace scoping, retry policies, and etc. It's using MDNS and round-robin load balancing to distribute the calls to your services. It brings tracing, observability, and access control, everything out of the box. And so you will have these fancy features without any additional sidecars, without DevOps engineers and etc. You can write down everything in the config files, and it will be the same for all environments that you're deploying in your DAPR application. And now let's bring even more details. Azure Functions extension. It's plugin that still is in preview, but this allows to port your serverless application that's running natively on the consumption plan to your DAPR application with containers, containerize the functions, and run them on premises or everywhere you want to. And with Azure Functions applications, You can have your DAPR cluster with the help of the cadre scale it down to 0 if you have an event-driven system like you're using some kind of a broker, service bus, or RabbitMQ. So you can create your Azure functions and subscribe to the DAPR endpoints externally or internally, and use Azure functions in cloud or on-premises to integrate with your DAPR code. So I want to emphasize again why DAPR. It's for developer, not a DevOps. It's not a service mesh, but it supports namespaces and access rights, so you don't have to deploy service mesh to limit your service connectivity. It have a lot of building blocks and supports a lot of external storages, message brokers, key vaults, and etc. It can be used together with other service meshes on the Kubernetes if you have existing infrastructure and want to adopt the DAPR. And it allows for your solution to be ultra portable. And it's really shines with newest stuff provided by Azure, like container apps, and probably more and more clouds will be providing kind of serverless container service that will be supporting the DAPR out of the box. So from service mesh to DAPR. Let's cover briefly service mesh and DAPR differences and what's the main goal here, what's DAPR solving here. So problem with microservices. Each microservice usually can call any other microservice, and this can result into the messy application that will bring a lot of hassle and a lot of issues for you. And you should limit somehow your application and allow service B1 should call only service C1 and not other ones. And other communications should not be allowed. The service meshes for Kubernetes, it's usually about network limitation and structuring connectivity patterns between your services. And it's 99% that this is DevOps problems, and developers don't want to do anything about them, about configuration, etc., and don't want to use them actively. And developers just dropping out responsibility for service discovery and etc. So service meshes have a particular benefits. It's traffic load balancing, routing and splitting traffic, resiliency through retries, distributed tracing, which is super important for microservices, service-to-service metric connection, so you will understand how much data lived in between services, service-to-service documentation with mutual TLS, and it's super important because setup of the security of infrastructure, of certificates expiration, auto rollover, and etc. is super painful. Flexible access control, so you as developer or DevOps can explicitly state which service can connect to the which one, and which load balancer can connect to which service. And usually, as I mentioned, service meshes is DevOps engineer responsibility, so developers don't have even an idea of the problems in the applications until DevOps escalate them. So what lessons learned from my usage of the DAPR and its adoption? It's super easy to change the components. It's easy to lift and shift. It's have limited support of the message brokers in general availability. It's Azure Service Bus, ready streams, but a lot of brokers is coming to the production this spring. It uses different stores in general availability: MongoDB, Redis, Azure Cosmos DB, and Azure Blob Storage. But SQL Server, Amazon Redshift, and other storage services coming now, and they still in preview. Limited feature support. You will not have all feature support of the Azure Service Bus or any other service. You will have a basic functionality. So for the PubSub, you will get subscription and publish. From RabbitMQ, you will not get deep detailed configuration, different types of the queues like durable queue. No message TTL for Azure Service Bus or Kafka topic. This is kind of super, it's somewhat important because message time to leave configuration is what I'm usually using in production. Not dead letter configurations. Dead lettering is responsibility of the DAPR, and you can do the fine tuning according to your needs with underlying services. No specific configuration like max batch size and how many messages deliver to your DAPR application in one batch. But otherwise, it's evolving, but you will not have all deep configuration and detailed configuration as you get used to with other services. This is a brief slide about different methods of calling the DAPR runtime. So you can use a .NET SDK, you can use HTTP requests, or you can use JRPC calls. And this works the same way, but obviously from the developer perspective, it's super easy and super nice to use SDK. Statestore consistency, it's also kind of important questions. You can read about this in details later on, but at the moment, DAPR Statestore supports only key value pairs. It's using model of distributed data consistency. It provides concurrency consistency configuration and its defaults to the eventually consistent and uses last write wins. It can be configured, so depending on your application, you can switch this behavior. And it's using transactional stores only for actors. So if you want to use transactions, you should use actor frameworks with standard Statestore components. It's not available for you. Who is using DAPR? A lot of companies already adopted DAPR as a base for their microservices. You can find on the slide. And more companies adopting it or migrating existing infrastructure to speed up their delivery and to make applications truly portable between different clouds. You can find all details on the GitHub of the DAPR framework. They have an adoption page and links, official links of the companies that adopted it. So let's talk about briefly problems. All problems is usually created by you, but it's better to be aware what you might encounter with the DAPR. Switch of the load balancer on Azure from the standard load balancer to the something like Nginx and switch of the reverse proxy might broke your cluster. So it cannot be done with a canary deployment, but it goes the same way with any infrastructure manipulation. So sometimes you need to recreate a load balancer from the scratch. Crash loop backoff of sidecar container can be misleading, and sometimes it's a misconfiguration issue. And you will be thinking that it's a problem with your application. So you need to have a proper monitoring and logging in place for this. Multiple installation of DAPR, unfortunately, can be done in the same Kubernetes cluster. This can result in a lot of issues and a lot of hassle. If you have already existing Kubernetes microservices, DAPR will bring overhead for you, unfortunately, and there is nothing you can do with this. And this will bring overhead for DevOps engineers, because if you already have some kind of a service mesh like Istio or something like this, there will be two meshes to support. One will be supported by developers and another one will be supported by DevOps engineers. So where are we heading with the DAPR now? We head into the serverless containers, and I will talk about Azure Container Apps in a minute. It's super great, and it's kind of best service for host your DAPR application outside the Azure Kubernetes service. We're heading towards serverless containers with cross-platform compatibility. And as I mentioned, DAPR is open source. It's supported by Microsoft Teams and supported by CNCF community. It's already donated there. There are also frameworks like .NET TIE and KEDA. Also, KEDA is open source from Microsoft. TIE is kind of helper to build containers and work with containers at will. We also heading towards that the shipping of the code, running of the code, and infrastructure is a developer responsibility. And there is a tools to write infrastructure with your own language. So it will be less of the hassle and no JSON YAML programming in the future. Probably Microsoft will unify the frameworks like TIE, DAPR, and KEDA. At least they will try to do this under one service. And this service is actually Azure Container Apps. It's still in preview, but it's already working good. And Kubernetes management or configuration would be only for super complicated projects with hundreds of services, with on-premises cases, and etc. So Kubernetes will be like exotic stuff and would be needed to manage under some edge cases. But there's a rival orchestrator like Consul, and it's probably will introduce some competition to the market itself. And now let's switch to the fun part, the Azure Container Apps. Because DAPR is a kind of essential part of this container apps, and this is kind of something that I'm super excited for. So Azure Container Apps, it's basically serverless Kubernetes, and we will cover this briefly, and then we will look into the Azure portal with the serverless Kubernetes offering from Azure. So let's do the short review. It's powered by Kubernetes, DAPR, KEDA, and Envoy. And Container Apps allows for event-driven scale in down to the zero. If you subscribe your scalers via DAPR or KEDA provider to some kind of a message queue. It doesn't provide any direct access to the Kubernetes APIs, but most super cool thing here is that you should not upgrade your Kubernetes cluster, never ever, and you should not maintain it, and you will be provided with HTTPS out of the box for your cluster, and you cannot configure the ingresses and etc. Everything is provided for you. You should not you can configure ingresses, and you cannot and should not set up anything to do this. And if you will be using DAPR, it will be super easy to port your application from Azure Container Apps to the Azure Kubernetes service, and then to the on-premises or any other cloud provider. And this service will provide a huge benefits in terms of cost efficiency and availability of your containers without any DevOps engineers. And this way you will be more experienced as developer, and you can concentrate just only on the business logic, on your application and DAPR configuration, and this will be it. It also allows for blue-green deployment, and it also have integrated secret management and is integration with Azure Key Vault and etc. And in some way it provides experience of Azure Web Applications or Azure Functions, but we will look into this slightly later on. And so I'm kind of super excited about this, and it will be super fun to use once it will be generally available. As of now it is in preview, but I think it will be released soon enough so we can use it in production at will. And we're moving forward into the details. So it can handle multiple container revisions without a scale. As I mentioned, you can have ingresses without another external configuration, without creating any real infrastructure, because everything will be done for you. You can have a virtual network integration, which is super important for enterprise customers. You have a built-in DNS-based discovery, but if you already listened a few slides before about DAPR, it's basically provided by the DAPR framework. At least it's my understanding. And out-of-the-box secret management and observability, which is super critical. And DAPR with KEDA was meant for this service. And yeah, it's have a wide range of scalars, and this wide range of scalars can provide real-life serverless approach to your workloads with a little bit of a cold start for sure, but still with a lot of savings for your budget. So we will move in now to the demo, and this is sample UI. I just kept this into the slides so you can see for yourself if you don't want to watch the demo later on. The container apps have the same approach as the classic Azure services, functions, web apps, and etc. Almost any Azure Container Apps configuration blade provides configuration for DAPR components. You can set up them, you can integrate storages, service buses, and etc. right from UI, and hopefully this UI will be extended later on. But now we are preparing for the demo. Before the demo, you can scan my LinkedIn and Twitter profile to connect with me and follow me for more content on the DAPR, KEDA, and Azure Container Apps, or anything technical at all. But now let's proceed to the demo. And now we are at the demo, and as you can see, I opened the Azure portal, and you can see the resource group with container apps. And let's have a brief look into the container apps applications. So basically we have a log analytics workspace for the logs. We have a container app environment, which is just an aggregator for the container apps. We see the two container apps here. And if we will return to the resource group, we can open the first MS stage container app, first one. And let's see that it's actually a container app, and we can see that it is actually a container app based on Kubernetes with a real endpoint URL. Let's open it. As you can see, it's obviously a shared compute and a cold start, but it will load in a second. Meanwhile, we can open our configuration settings. Let's see that we can add secrets as easy as a key values in the web app environment. Also, we can set up ingress here via configuration. It will load right away. It's already enabled for us. It's HTTP ingress, and you can switch target ports and anything like this. As you can see, As you can see, there is HTTP ingress already set up for us, but we can limit ingress traffic to the container apps only, or limit it to the VNet if we will create container apps with VNet integration, or switch it to the accept traffic from anywhere. Now let's switch back to the continuous deployment, and here you can see the classic integration like with the web apps. You can sign into the GitHub to pull your containers from there, and you can set up container registry to subscribe to your containers here, and also you can just put a physical file location for Docker file, and you can set up a service principal for your service, so your Azure Container Registry will be always authenticated with your Azure Container Apps. Basically it's Kubernetes, and everything would be automatically deployed there. There is also important thing here, it's revision management, and as you can see there is a one revision of the container that we deployed here. You can create a new revision or choose revision mode basically. And if we will open container revision here, we can see this application URL, and if we open the URL here, we can see that it's available now, our container app Black Island, but we can open exact container here from this application URL. You see the difference in the URL: MS Container Apps, Black Island, D3C, and this is the root URL. So your different application in Kubernetes in Azure Container Apps / Kubernetes service can be available separately if you configure them to do so. Also, here is the revision settings. As you can see, it's shared compute with half of the core and 1 GB of RAM. You can choose different scaling rules here, but as you can see, it's immutable, so you cannot change the DAPR or scale configuration. But if we will return to the container app and we'll create a new revision, we can add a new postfix here, configure the scale. Now it's 10 instances, but it will be up to 25. And if we will enable DAPR settings, we can configure the port, application ID, and so on, and configure DAPR components and everything we want to use. So it seems super straightforward, and it's really working. And this is the magical stuff about these container apps, because going forward it will be a super easy tree of decisions. So it will be serverless first, like Azure Functions on the consumption plan. Then it will be something like if you need to integrate in Azure Functions with Enterprise, it can be premium plan with integration to the VNet. Then if you need more container applications, you can choose Azure Container Apps and deploy your containers there with DAPR or without DAPR. And the third step would be Azure Kubernetes Service that you should manage and configure by yourself. And the last step would be full-fledged Kubernetes deployed to the on-premises or any other cloud. And for me, I don't see a lot of justification of using a full-scale Kubernetes anymore. Even usage of the AKS for workloads that are not super heavy might be not necessary at all, because I rarely seen super complex applications deployed to the AKS. And so we have a super brief look into the Azure Container Apps. And now let's have a brief look into the actual DAPR application. It's a classical .NET application with nothing fancy in here. It's even old framework. It's not yet 6. I have not upgraded this application in time for this workshop. But actually, you can see that we're using DAPR as ASP.NET Core 1.3 here. And as you can see, it's set it as a standard service here. So nothing fancy, just using of the DAPR. So nothing fancy here. And we have a standard order controller. And here in order controller, we have a DAPR client impact. And this DAPR client impact just using this super simple code that will publish our event to the pub sub endpoint with type of create delivery. And when we publish in this message would be available on the application tPaper delivery. And I will share the GitHub link in a few minutes. And if we will open the startup of this project, and when we will open startup file of the project DAPR delivery, who is receiver of the DAPR message, we can look into the startup file and see the same add DAPR here, but with another addition, use cloud events. Cloud events is typical, it's a standard of a message exchange for the DAPR. And so we can open a delivery controller and observe that we declared attribute pub/sub create delivery. It's the name of the pub/sub component here, and the method will be triggered. If it is a pub/sub service, name it pub/sub, not very good, and create delivery method. And so this controller and this project would subscribe to this create delivery endpoint, and as you can see, method create delivery just accept the delivery. It already will be deserialized for your convenience, and you can just process it at will and save it to the database. And to speed up this talk and to not spend your time, you can just navigate to my GitHub, github.com/Lebedenko, and you can just open the DAPR partner workshop and download this application and try the DAPR for yourself. It's super convenient, super easy, and this repository executed step by step. It's super easy to start, it's super easy to configure this stuff, and it truly will make your applications portable. And so my recommendation to fetch this repo, hit a star, and use it for your convenience. So this is the end of this talk. I hope you enjoy it, and I hope you get something useful from this talk. If you have any questions or suggestions, just ping me back via contact information. And thanks for watching. See ya next time. And don't forget to watch other talks here on MS Stage. Cheers!